Today we're talking about relations and functions. So let's start with, what is a relation? What is a function? You should be familiar with the Cartesian coordinate system and graphing in the xy plane. So here is the x-axis. The horizontal axes we generally refer to as the x-axis. The vertical axes we often refer to as the y-axis. However, there are situations where we use other variables besides x and y, but this is the Cartesian coordinate plane, and it's made up of ordered pairs. So suppose you wanted to plot the point 1, 3. Well, the first thing we need to do on a graph is always have a scale. So I'm going to count by ones. I'm going to mark a 1 here and a 1 here. And I don't have to mark all the numbers all the way across the scale. I just need to make sure it's clear what I'm counting by, and I'm counting by single units. So the coordinate 1, 3, we're going to do the x coordinate is 1, the y coordinate is 3, and we plot this point. Suppose we have the point -2, 5. Now in the x direction, I'm going to go -2, +5, and I would plot the point -2, 5. So hopefully you are all familiar with plotting ordered pairs. Here's a set of ordered pairs that are on a Cartesian coordinate plane. And the question here, state the domain and range of the relation shown in the graph. Is this relation a function? Well, first of all, what a relation is just a set of ordered pairs. So here we have a set of ordered pairs that are graphed, and we have our set notation. So we have -4, 0, -3, 1, 0, -2, 1, 2, and 3, 3. This is a relation. The domain is the set of all the x values. So our domain is -4, -3, 0, 1, 3. The range are all of the y values. So we have, and I'm going to start at the lowest number and move my way up. So I'm looking at the second ordered pair. So we have -2, 0, 1, 2, and 3. And that's our range. Now the next question here is this relation a function? In order to be a function, a function is a relation in which each x value, or the value in the domain, is paired with only one y value. So when we check this, we have to make sure that the x values don't repeat. And here, since none of our x values repeat, they're not paired with an additional y value, then that means this is a function. So the answer to this one is yes, it is a function. Now there's a way that you can tell if you have a function or not from looking at the graph, and that's called the vertical line test. So here I have a vertical line, and if I take this line and run it across my graph, I can only hit one point at a time. So you see as I'm moving this across, I only hit one point that's in my relation at a time, and that's a really quick, easy check to tell if our relation is a function. Here's another example, and you might not want to copy this into your notes, so you can go ahead and just listen. So here the table shows the average fuel efficiency in miles per gallon for light trucks for several years. You're asked to graph this information and determine whether it represents a function. So here we have the years given, and we have the fuel efficiency in miles per gallon. Now the first thing you would want to do is set up your scale for your on your axes. So we would put the year on the horizontal axis, and we can put the mileage on the vertical axis, and we would actually say that the year is called the independent variable, and our mileage is called the dependent variable. And one easy way to think about that is our mileage depends on the year that we're talking about. So if I wanted to know what was the fuel efficiency in miles per gallon, you might say, well, that depends on what year you want. So the independent variable is the year, the dependent variable is, again, the mileage for this example. After you set up your scale, and one thing to pay attention to, make sure that you have equal increments on your x-axis as well as on your y-axis. You would have equal increments, and the little lightning bolt here is just to signify that some values have been skipped. Then once you've done that, you would plot the points. So 1995 was 20.5 miles per gallon, so you'd mark a point there. Continue to do that for your data, and then the question was whether or not it was a function. If you use a vertical line test and run a vertical line across, you'll see it will not cross 2 points at once. So according to our vertical line test, that means yes, it is a function. Here we're asked to graph the relation represented by y equals 3x minus 1. So what you're going to do on this problem is start with a table of values. Actually, relations you can think of three different things. There's a rule, which in our case is y equals 3x minus 1. There is a table associated with that rule, which we're going to create, and there is a graph associated with that rule and that table. So every relation can be expressed by a rule, a table, and a graph. So we're going to choose some values for x, and it's completely up to you the values that you want to choose. I recommend that you choose some negative values. I'm going to choose -2, 0, and 2. Then to find out the values associated with that, I need to substitute the -2 into my equation. So I'm going to have 3 times -2 minus 1. -6 minus 1, so we get -7. Substitute in a 0, and we get -1. Substitute in a 2, and we get a 5. Plot those points. Don't forget to show your scale. -2, -7, 0, -1, 2, 5. So I plot those points. Then I'm going to draw a line. And draw arrows at the ends to represent that my line could keep going. Now, the reason why I drew a line was because I could have picked other values besides -2, 0, and 2. You may have picked a 1. You may have picked a half. You may have picked 1.23587. Any value that you want to pick for x, you could substitute that in and find a corresponding value for y. Any value you pick, you will find that the corresponding y value, when you plot the ordered pair, it will end up on this line. So if this is our graph of our relation, what's the domain? Now sometimes students will say, oh, well, the domain is -2, 0, and 2, because that's what I put in my chart. However, you could have put a -3 in your chart, or a 1/2 in your chart, or like I said, you could have put a 1.37285. I don't remember what I said before, but you could pick any value that you want to pick for x, which means that the domain is all real numbers. Remember our symbol for all real numbers. Our range, if you notice from our graph, notice how I have an arrow that goes up, an arrow that goes down. It covers all of the values of y. So for my range, it is all real numbers. So is this relation a function? Does it pass the vertical line test? Yes, it does. So y equals 3x minus 1 is a function. For the next graph, or the next relation, we're going to look at x equals y squared minus 2. Now this is a little different. Notice that instead of y equals something in terms of x, we've got those switched around. So when you make a table of values, I'm going to list them as x, y, because when we do our ordered pairs, we plot them that way. But here you're going to want to pick values of of y instead. And I'm going to actually pick a few more values on this one and substitute the values in. So if you substitute in a -2, if you square a -2 and subtract 2, remember when you square a -2, you get 4 minus 2 is 2. Next, I'm going to square a -1, and when I do that, I get 1 and subtract 2, and I get -1. Square a 0, you get 0, subtract 2. Square a 1, you get 1, subtract 2. And square a 2, you get 4, and subtract 2. Now let's see what we have. Scale my graph. 2, -2, plot the point. -1, -1. -2, 0. -1, 1. 2, 2. Now when you draw this in, you're going to get a shape that looks like this. It's not pointed at the end, it's just kind of hard to draw that in. But we get a curve shaped like this. This is the graph of this relation. Now the question is, well, let's do the domain. So the domain, can x be anything? Notice the values. Look along this direction. Notice that the farthest to the left we go is -2. There's nothing smaller than -2. So our domain, x is greater than or equal to -2. Our range, take a look at the arrows. Notice how this continues to go up, and this arrow will continue to go down. So when we're looking in the vertical direction, we see that it's going to cover everything. So our range is all real numbers. Now, is this a function? Well, let's see if it passes the vertical line test. Since I can draw a line that passes through 2 points, that means it is not a function.